I need to get you guys to a good spot. I need to get you guys to a good spot where you can be able to handle some of this material. And I know you saw a couple videos, and a lot of you guys understand what you need to know about the chain rule, but you may not know it well enough yet, okay? And so let me just start by this. The chain rule is actually dubbed the chain rule based off of this concept. If you have 3 different pulleys, notice in this situation, we're not going to do this problem right away. We're going to start with some basic ones. But it says f of x is sine, people, quiet. Sine squared of 4x, we have 2 parts of the chain rule there. We have our inmost function, which is 4x. We then have another inner function, which is sine of u, or that 4x. And then we have this u squared portion. So if you notice, if you ever plug a value in for x, after you plug in the value for x, you're going to take the sine of that 4x. After you take the sine of that 4x, you're then going to square it. So if you could think of it in terms of a, what you guys maybe do in a science class, think about this. If you put a belt, so to speak, around that pulley, and then it turns that pulley, which in turn pulls that pulley, so on and so forth, true or false? These pulleys are all going to be rotating at exactly the same speed. False, because they have different radiuses, right? They have different radii. And so therefore we have different rates of change, and we have to compensate for the different types of changes that are happening. That's why the chain rule exists. To recognize that when you have composition of functions, that there's something unique happening. So when you see the chain rule, you should be thinking of this picture in your mind. That you have, sure, belt, however you want, chain. I could have put, you're right, Tyler. I was going to put like little spokes here, but then everybody would just start making fun of my drawings. And so, see, and there it goes. Now it starts, right? So, I put a W because I don't want to use U again. I've already used that up. So I really have 2 inside functions that are taking place. You're a stupid drawing. Okay. Here we go. You should do the chain rule. And if you like setting up like this, you're more than welcome to. If you don't, that's fine. But there will come a time, yes, there will come a time where you will no longer set them up like this. If I take the sine of 4x, I know right away it's 4 cosine of x. Of 4x, excuse me. And that's what I do. So if you want to take the derivative of a composition function, here is the rule. You do f prime of u, so you leave the inside alone. Some people say it like this: the derivative of the outside with the inside left alone times the derivative of the inside. And so you got f prime of u times u prime of x. So last year, like I said, I was gone for a day, and I wanted to instruct my class on how to do the chain rule, and they had never seen it before. And so when I was gone, I just made a video, and I did this. And as you can see, I got this graphic organizer on the front. Well, the backside has absolutely nothing. When I came back the next day, they had all written the boxes in there. And they said, well, we thought we were supposed to do that. Someone said, well, I didn't think I was supposed to do that. I just did that because I thought it was helpful. It doesn't matter to me. But at the end of the day, when I take the derivative of that, again, negative 12 cosine of 4x, I'm not going to set up the box every single time. So, but there are times where it's helpful to continue to set it up. So let's review what we've done before. Here's the organizer. I always identify the inmost function first. What is the inmost function? 2x plus 3. What's the outermost function? U to the 4th. I take the derivative of each. What's the derivative of u to the 4th? 4u to the 3rd. What's the derivative of u? 2. What? 8u to the 3rd. Exactly. Now, do I stop there? No, I must plug u back in. So 8u to the third is the same as 8 times 2x plus 3 to the third. So that arrow reminds us to plug it back in. Question. I will admit I was kind of sad. As I went through some of your guys' quizzes and tests, I did see a lot of this. I saw a lot of 16x plus 24 to the third power. That is so illegal, I can't tell you how many mathematical laws you just broke doing that. So, you guys, order of operation says you have to cube this first. You have to take 2x plus 3 times 2x plus 3 times 2x plus 3 first, and then you can distribute the 8. Yeah. No, I felt bad that we were making that mistake. So, anyway. All right, let's fly through these. What's u of x in this situation? So u is 1 minus 2x minus x squared. What is f of u? U to the fifth. What is f prime of u? 5u to the fourth. What is u prime of x? Negative 2 minus 2x. Now, I can multiply these together, and I can distribute the 5 to both of those terms. That will leave me with negative 10 minus 10x times u to the fourth. So now I can plug my u back in, and I get negative 10 minus 10x times 1 minus 2x minus x squared all to the fourth power. Now let's pause and reflect. 1 minus 2x minus x squared to the fifth power? Really? You want to multiply that out 5 times and then take the derivative? That's absurd. The chain rule is incredibly efficient. It's amazingly simplistic when you think about it. Right. So we're going to practice the ones that we know how to do, but that was part of my study. The study did, I pushed you guys to learn content that you weren't ready for, okay? So this one, I need to rewrite it. So before you guys said, let's use the quotient rule. Forget about the quotient rule. We can rewrite this using the chain rule. 3 times 4x minus 2 to the negative first. So what's the inside? 4x minus 2. What's the outside? 3 to the negative 1. Very good. What's the derivative of f? What's the derivative of u? 4. Multiply them. Negative 12 over u squared. Negative 12 over 4x minus 2 quantity squared. You guys try the next one on your own. Go do number 4. Practice on your own. I'll work slowly behind you. You can check to see if you did it right. Shh, boys and girls. Okay, I want you to understand something. Notice that when the derivative of the inside is 1, all you need to do is really just take the derivative of the outside with the inside left alone. So the rate of the change of the inside is just 1, so therefore it remains a constant 1. It doesn't change the outside at all. So this problem works out very, very well. Any questions there? Okay. This is not cosecant squared. This is cosecant of 3x squared. What's the inside? 3x squared. What's the outside? Cosecant of u. What's the derivative of cosecant of u? Need to memorize it. No, this is from last week. This is not on your trig sheet. This is a calculus piece. The derivative of cosecant is negative cosecant cotangent. Probably Thursday, Friday last week. So that piece you got to know. Derivative of u, 6x. So now I multiply it together. Negative 6x cosecant of 3x squared cotangent of 3x squared. That's my derivative. Yeah. Once again, pause and reflect. How complicated would that be to try to solve without the use of the chain rule? Now, a lot of people, when they see problems like this, they're like, Mr. Gens, is that sine of x times tangent of x, or is that a composition? Well, it's a composition. There's no sine of x up here. There's a sine of something. So on the test, one piece that I learned that you guys need is you want me to insert those parentheses, and I will do that all the time, okay? But right here, you need to recognize that this is composition. A lot of people, when they get to the test, they do this as the product rule. You have to be able to decipher on the test when to use the product rule, when to use the chain rule. Okay? This is a chain rule problem. What's the inside? What's the outside? What's the derivative of sine of u? What's the derivative of tangent? Secant squared. On your test, the first part of your test will be to memorize all 6 trigonometric derivatives. If you don't think you have one of them correct, you can ask me for one of them, and I'll subtract that point from your test, but at least you'll have it the rest of the way. I now multiply these together. No. Nope. I got a good idea. How about you just memorize the 6? You guys could do that. Times cosine of I'll write it on the board later for you so you guys can memorize it, okay? So, you guys, I just did these 6 problems for you. I want you to look at this worksheet. This is really what you needed the past couple days that you didn't get in order to help your learning. And this is where I want to pause, okay? You guys, when you get to college next year and your professor does not give you problems to practice that you need to recognize for yourself. You need to say, hey, I need to practice some basic problems. Then you got to find those. You got to talk to somebody or your professor, but you got to get those basic problems in your belt. So this is for you to be able to practice that basic piece. I give you right now 5 minutes, because then I want to go on to the other stuff that's just a little bit harder. You have 5 minutes to practice the easy stuff. I don't care if you draw the graphic organizer. Here's what Trevor Keim did, and this is the most often what people do. He was part of the graphic organizer group, but he didn't actually draw the boxes. Here's what he did each time. F of u, u of x, f prime of u, u prime of x. He did that one time. The next time he didn't even write those. He just did this. He did 1 minus x, u to the 9th, 9u to the 8th, negative 1, and they multiply them together. It's the same idea. It's organizing your thoughts in a 4-tiered format. You got 5 minutes. Knock out some of these problems. Go. This will be an assignment, so I'm giving you some time right now, so please use it wisely. I'll put the derivatives right up on the board right now. We're going to go to this section right here, okay? on your worksheet, none of them involve the product rule and the chain rule, or the quotient rule and the chain rule. Those are problems I'd like to model right now. But again, I want to show you how you can model your thinking again. All right? What's the inside function here? What's the derivative of it? 3 times. What's the outside function? What's the derivative of 2u to the 6th? 12u to the 5th. So you can see that you can actually get through some of these chain rule problems pretty quickly by looking at the derivative of the inside times the derivative of the outside with the inside left alone. So now all I have to do is write it as 36 3x minus 5 to the 5th. So all of a sudden I've made pretty easy stuff out of that, okay? Now, I want to show you guys this because when you come back on Monday and Tuesday, and we're going to test next week, but we're going to be able to review some of the basic chain rule pieces again, all right? Watch your next one. I rewrite this. How should I rewrite this one? Seven minus 4x to 1/3, right? What's the derivative of the inside? -4 times, what's the derivative of the outside? 1/3 u to the -2/3. Now we simplify. Cubed root. Or you could write it as to the 2/3 power on the bottom. Now, I want you guys to understand that if that's too quick for you, then you write it out using the graphic organizer every time. But I want you to know that that's probably not what your professor's going to do next year. He's going to look at it, and you're going to go. Okay? So, let's do one more. Let's do D. I'm going to propose to you that D is a pretty easy problem to do the chain rule for. What's the derivative of the inside? 10x. What's the derivative of the... Oh yeah, 10x to the 4th, right. Times, what's the derivative of the outside? Secant of u, tangent of u. So I took the derivative of the inside times the derivative of the outside with the inside left alone. And so now all I have to do is multiply and put in my u's. So -40 x to the 4th, secant of 2x to the 5th, tangent of 2x to the 5th. I know where we're headed, and where we're headed is being able to take this and get back to there. So I want you guys to know we're taking derivatives. Calculus 2 is, well, and part of Calculus 1 is taking antiderivatives, which is much more complicated process. But as you guys understand the chain rule, it's so important for you guys to be able to go the other way. And trust me, you will be able to do it. You'll be excellent at it. Okay. Ella says why. Let me tell you, there is something absolutely amazing that you can do with antiderivatives. In fact, it's called the fundamental theorem of calculus. Okay. Oh. Good chance, Taylor, that you will never use this in your career. Okay, good question. So you guys ask a very good question. Can I just show you an example real quick to try to? Okay, so um, this is something that Andrew's been asking about as well, but I just told you guys the instantaneous rate of change piece. Watch this. Suppose that that's a function bounded by A and B. And I want to know the exact area. I don't have a formula for that. I don't have a circle formula. I don't have a triangle formula. I've got nothing. I can figure out the exact area bounded underneath the curve between two pieces in probably about 10 seconds. I don't have a function right now. You're putting me to a challenge. All right. Here you go. I got f of x is equal to x squared. Shh. Oh, yeah. Let's see you guys do it. What's the exact area bounded between 0 and 2? Eight over 3. You guys trust me. All right, all right. Well, you guys will just have to wait and see because it is unbelievable and you'll be able to do it as well. And that has all sorts of applications. All sorts of applications. Okay, so. Okay, letter A. Find the derivative of the following. It says you may need to use more than one rule. Greta is almost correct. We don't have to use the chain rule twice. What do we need to use? The product rule along with the chain rule. Andrew. You can do that, yes. You should have the product rule memorized. So, the product rule, that's something that we have to recognize. You have a function times a function. So you can see that you have two pieces. We have this one. We have this one. And notice that this one right here is also going to involve the chain rule. Shh. Boys and girls. Shh. So unless you're helping me with the problem here, please be quiet. So we have f prime of x is equal to, what's the derivative of the first part? Times the second part left alone. Cosine of 4x. Plus, we don't know what the derivative of g is, but do we know what f is left alone? What is f left alone? Negative 3x squared. Times, we've got to find the derivative of cosine of 4x. Negative 4 sine of 4x. So I'll set it up, but I just want you to realize that you've now learned how to do that in a pretty quick way. I'll show you. The inside is 4x. The outside is cosine of u. Everybody agree? What's the derivative of the inside? What's the derivative of the outside? Negative sine of u. So as you multiply them together, you get negative 4 sine of 4x. So we can change that minus to a plus 4 sine of 4x. So if I write this out, I have negative 6x cosine of 4x plus 12x squared sine of 4x. And once again, as you look at it, again, try to think about using the formal definition of the derivative in order to find that. So we've come a long way in terms of being able to find derivatives of any type of function. And we will be, I mean, you guys are seeing we're going to take the derivative of anything. Anything that comes our way, we should be able to do. Okay? Yep. Let's do one more. Obviously, what is B? B is chain rule with the quotient rule. What do you have to do first, the chain rule or the quotient rule? Quotient first, then the chain. Look at C. What does C involve? Quotient and the chain. What do you do first? It really depends on how you set it up. Okay? D, yes, you need to use chain rule for the top and the chain rule for the bottom. So, let's try D. For letter D, I have negative 8 sine to the fourth of 4x minus 2. Here you need to recognize that you have what? Do you have the product rule? No. Do you have the quotient rule? No, but I have the chain rule twice. I have 4x minus 2. That is one of the pulleys. I have another one. I have sine of something. Okay, then I have this, negative 8 to the u to the fourth piece. So let's just start by setting it up. What is not my, I don't want to start with the inside most piece. I want to start with the second to most inside piece. How about this? Let's focus on the, let's focus on rewriting it first. This will help you. Negative 8 sine of 4x minus 2, and I'm just taking the sine of the 4x minus 2 to the fourth power, correct? So let's start here. Normally we identify the inside. Sometimes if you have two of them, it's easier to identify the outside first. Anybody see the outside? Negative 8 u to the fourth. So that's going to be an outside part of the function. If that's the outside, what's the inside? Sine of 4x minus 2. What's the derivative of negative 8 u to the fourth? Everybody okay with that so far? What's the derivative of sine of 4x minus 2? Got to use the chain rule. So, I'm going to set it up again. Okay, I'm going to set it up again. What's the outside part of this? Sine of u. What's the inside? 4x minus 2. What's the derivative of sine? Cosine of u. Derivative of 4x minus 2. So if I multiply those together, I get 4 cosine of 4x minus 2. So now I have that derivative. So now I can take and multiply them together, correct? Negative 128. You could have cosine of 4x minus 2. That'll be fine. And then we have u to the third. So sine to the third of 4x minus 2. And that's that derivative. Nope, done. Well, it's u to the third. So remember, we have to plug that back in here. So sine of 4x minus 2 to the third power is sine to the third. Question? You have the third here, or you have the third here? If you want to, you could take this and go like that. That would be okay. That's fine. That's fine. But that third power can go right there. Okay, your goal this weekend should be this. Get caught up on all of your homework. Finish the worksheet I gave to you. And then on Monday, I'm going to give you a more difficult assignment on the chain rule. Do you want some of those problems right now? Okay, so get caught up and be moving from there. 1, 2, and 3. Question.